knowing the amount of rats per capita, perhaps we do, but not in Alberta.
Yeah.
Okay, well now after our extreme sidetrack tangent thing, let's go into the lesson. So I made my kind of silly comments about grades, if you have a real high outlier, real low outlier. Then we talked about Big Money Jawad over there with his, thousands of stacks in his bank account, making the rest of us seem like paupers, and bringing up the average wealth in our classroom by a lot, maybe, in this imaginary universe we're talking about. So the big idea today is sometimes in a set of data there's an outlier. And that outlier dramatically impacts the data more than a piece should. And this is partially because with numbers, when you're dealing with numbers that are like proportionally significantly different, you can really change calculations dealing with that set of data. So let's look at Lukosi cutting lawns to earn extra money. He charged $15, $20, $15, $25, $100, and $20. Okay, so let's see, what was the mean amount of money he charged? Well, how do we find the mean? We take the amount, 15 plus 20 plus 15 plus 25 plus 100 plus 20. And we divide it by the total number of data points, which here is 6.
Bro, what old lady did he scam?
160.
190.
195? 6. Please remember that this is money, so we don't just put 32.5, right? 3250 is how you would say that in your dollars. Now, what do you notice? What's the issue? Yeah, but even our average, you're right. Obviously, $100 is what causes the issue. You're totally right. But looking at 3250 as the average, if I just thought about the numbers that we charge 15, 20, 15, 25, 20, and 100. Yet our average is significantly higher than all of these numbers but one. So does it make sense? Well, I guess you could say you probably understand why the number came about, right? It makes sense in that you know why that is. It's not like there's a mistake, but it doesn't accurately talk about the kind of central measure of this data. Or we could say it isn't I would say it isn't a great indicator of most prices, right? In general, the prices are not averaging at 35, even though that is the brute force average price. But it's really being blown up by this $100 one. And this would be even more stark if, let's say, we think about the situation there. So in general, maybe this first one took like half an hour, maybe 45 minutes, maybe half an hour, maybe an hour, maybe 45 minutes, something like that. I would suspect this one took maybe 2 hours or 3 hours. You can see it wasn't like the same amount of work. Now, this is a totally out of left field example, but have any of you guys ever heard of the Red Green Show? Old show, it used to be on the CBC, and it's kind of aimed at people like my dad. It was about like a fix-it handyman kind of redneck guy who would, his main line was, if your wife doesn't find you handsome, make sure she finds you handy. Right? And it's all these stupid inventions they make and all this kind of stuff. Anyway, it's quite funny, but he has this one bit that I've always stuck with. It's actually good advice. It was talking about a to-do list. And you know how sometimes you'll have like a to-do list? So for me, it's like, okay, mark 30-3 exams. And then it's like, do the attendance for this thing. And you want to make sure that each point on your list is like somewhat proportional to how much it takes. So here's the issue is, what if my to-do list at home is like, make supper, replace my furnace. Like that item takes a lot of steps. And what Red Green said is, you need to make sure each step in the big job is accounted for as like a separate menu item. So if it's replace the furnace, number 1, call 911. Number 2, unattach the gas from the house. Number 3, detach the line. Go through step by step. Because replacing the furnace is not the same amount of time as making supper, right? And so recognizing in this case, probably these items aren't all the same amount of time. It's probably not really the same amount of jobs. I bet you this $100 job probably took them all day. Whereas these are all probably like after school things or something like that, right? It's not really the same thing that's happening in those cases. Okay, I'll get off my soapbox here. The big thing is outliers. Outliers, there's a famous Malcolm Gladwell book where he talks about outliers, basically the impact of outliers on a data set. That's not the main point of his. The main point of his is that it takes a lot of work to do something great, but outliers are something that doesn't really fit with the rest of the data. Now, this doesn't make the mean invalid. It just makes it worth thinking that maybe trimming that mean is useful for figuring out the average of the normal part of the data. A trimmed mean just means if there's a really high outlier, take the top and bottom data points, get rid of them, and find the average with the rest. So it wouldn't be fair in a case like this to just take the 100 off, because that will skew the average down, right? But instead, if you're going to trim a piece of data off the top, do the same thing off the bottom, you're kind of finding the average of that 4 middle bars is what you're trying to do. So let's try to do this. Cutting the lawn again. Any outliers? Absolutely. Outliers, $100. So to find the trim mean, I'm going to remove this, but I'm also going to remove 1 from the bottom. I took 1 off the top, I'm also taking 1 off the bottom. So now my trim mean is 15 plus 20 plus 20 plus 25 divided by 4. By the way, without doing any calculations or any calculators, does anyone know what that means just by looking at it? 20 plus 20 plus 25 plus 15 divided by 4? 20. 20. Right, 80 divided by 4. Now, does that seem to describe this data more usefully? Or what do you think? I'd probably say yes, but, and we're not talking about this but, right? We're talking about, but there's a catch, right? There's a catch. Yes, but that $100 data point actually is a point, right? It's significant. It's not like a normal day's work, but it's still a data point. Okay, one more story that none of you care about hearing, but I'm still telling you anyways. So I used to do this job when I was a student. This is like, I did this after my first year at Red Deer College, and then I did it also 1 year when I was at U of A, where I installed screen doors. I'd like drive around and, there's a fur company called Solaris, installing those fancy screens. It's a pretty good job. I liked it. I got lots of autonomy, got to do different things. But sometimes I would get a tick. It's pretty rare. Sometimes I get a tick. So one time I did a screen door for this guy who clearly had quite a significant party the night before. Maybe wasn't exactly thinking the best. Give me a $50 tip. Suddenly my profits that day are pretty good, right? Okay, another day. This was actually the best one. I went to do this lady's house. She had 3 screen doors I was installing, so I installed these 3 screen doors, and she's kind of like following me around the whole time, like kind of annoying this lady. But I start realizing later on she's baking cookies. So this would actually be pretty good for her. I start being a little more kind and explaining what I'm doing and thinking, oh yeah, not that I'm transactional like that. Of course, I was just being kind out of the goodness of my heart. But we're going through these, and I get close to the end, and she's been talking to me. And that weekend, do you guys know the country music festival? It's called Big Valley Jamboree. They do it in Cameron's every year. I had never been to it, but I got free tickets from my boss that year. So I'm telling her about how I'm going to this jamboree, but I don't have my tent. My tent is at my parents' house in Red Deer. I'm going to need to get it. Anyways, I get to the end of this job. She gives me a plate of cookies, a tent that she just won at a silent auction, and $20 as a tip. That's a really different day. And I'm leaving that day thinking, holy smokes, this is the best job ever. Now, there are also, outliers that go the other way. But a day like that, it impacts dramatically how I thought about that job. It also impacts dramatically how much profit I was making in a job like that, right, Malak? You should not be on your phone right now. Don't be sorry, put it away, it'd be better. Thanks. Yep. Yep. But it's just worth recognizing. I still did get that profit, right? It's not like it didn't happen. By getting rid of that, by finding the trim mean, it's worth recognizing that is a more normal indicator of what that job is like. For me, not thinking about those days of least significant was a more normal estimation of what actually happened in that job. But they still were real days, right? It's not like they don't count. They're just not like the average thing. They're not the most common type of thing. So there's a bit of, as we were talking about yesterday, a bit of interpretation that's always necessary in data analysis is how is this information useful? What does it tell me? And what doesn't it tell me? And that's part of why trim to mean can be a useful tool in this arsenal. Okay, let's look at daily high temperatures in Calgary during 1 week in January. Now, Calgary is famous for Chinooks. We get them a little bit, but not nearly the same way. They're much closer to the mountains. Okay, minus 12, minus 8, minus 15, positive 12, minus 5, negative 10, minus 12. Yep. Well, because I'm saying, yes, I think this is more useful, but there's still a reason in which accounting for those outliers is important. I just didn't want to write all that stuff. I thought you could write it however you want to. But it's just worth recognizing the average still tells us something. It just doesn't maybe tell us the most kind of, when we're thinking of average, we're trying to ask what's like the most normal thing is, how would we describe this most centrally? And average is kind of meant to do that, but when we have a significant outlier, it gets skewed a lot, and that's why trim mean may be useful. Cool? Okay, temperatures in Calgary, so it's cold time in Calgary, but, you know, maybe there's one day in which the outfit changes a little bit. So, first of all, what's the mean temperature? Well, how do we find the mean? There are 7 days. We add up the temperatures, so it's all this stuff. So we could say it's the sum of that divided by 7. Uh-oh, I'm devolving, I'm getting lazy. Do you know what this sign is? It means add up all of something. So I'm saying add up all of that. Sum of those divided by 7. So negative 12 plus negative 8 plus negative 15 plus positive 12, okay, plus negative 5 plus negative 10 plus negative 12. Divided by 7. So the average temperature that week was equal to negative 7.1 Celsius. But there's a significant outlier, Wednesday, which was 12 degrees Celsius. So now if we want to trim this mean, we're going to take the top data point off, but we're also going to take off the bottom data point, right? If we're trimming it, we don't want to just skew it. We want to just adjust it, move it more inward, kind of. So now we're thinking, okay, negative 12 plus negative 12 plus negative 10 plus negative 8 plus negative 5, all divided by 5. A quick hint, if you're using one of these calculators, this is the negative button, this is the minus button. If you use the minus button for negative, you'll get a syntax error. Do I get off your phone? I should not see your phones in class, period. So, let's see, negative 24, negative 34, negative 42, negative 47 divided by 5. So now thinking about this, do you know where your book is? Oh, Rita's, you know...
I think I might have gone, and I don't want to write off.
Oh, you guys, remember, this is a very helpful thing for you to know. We have a book of shame.
Yeah, but like, I want to take a picture so I can do it all.
You have a book of shame.
Yeah.
You can write in it. This is for the person who forgets their book. You can use it for the day. Feel very proud of
No,
yourself.
this one over there. Oh, shit. I think it's not going too much. I think this is my last one.
So you came late without your book, and now you're asking to get it. So what do you guys think? What would be more useful? More useful. I think in this case the trim mean. That's more talking about what the normal temperature is. I think in this case the trim mean is more useful if you're trying to talk about what like the average daily high is, what you can kind of expect. I think that trimming the mean in this case helps you figure out what kind of the data is telling you on the whole. It's just worth recognizing these are both tools which tell you something slightly different. All right, last one. Outlier. Then calculate your mean to the nearest 10. So, we're going to then trim 20 and 2. So we're left with 3 plus 6 plus 5 plus 8 divided by 4. 22 over 4.
Isn't 24 divided by 4 6?
22 divided by 4?
Oh, you guys never played it.
9, 14, 22. Oh, here's why. We trimmed both 20 and 2. Right? Trim off the top of them. So the big idea, number that's higher or lower is an outlier. Calculate trim mean, remove the outlier, but also remove the opposite lowest or highest one. Good. Let's get to work. I don't think today this will take you the whole class. Let's see how we do.